All right, so today we're going to talk about SQL injection. I want to first start off with what is injection because SQL injection is just one type of injection, but let's look at a couple examples. So the first one I'm going to say is, say you have a website has a download file, allows you to put in a link, and in the back end, what it does is it takes that link that you inputted and it maybe runs wget and grabs the file, downloads it, maybe hosts it for you. Kind of nice. But it doesn't do any input validation. So you, as an attacker, can do this fancy thing where maybe you're catting the user's private key, and instead you're piping it back to a netcat command that is actually you're listening on your attacker server. And now you've just leaked the person's SSH key, and yeah, that's command injection. So the next one, all right, what's your name? So I'm gonna say my name is John. Well, it's this crazy little thing where it just kind of throws it into some HTML and prints it out for you and just outputs John. So what if we just put a script in there? So this one's actually referring to my attacker PC again, but it's tacking on the cookie. So I can put in, say, some basic JavaScript that should reach out to my server trying to reference an image, but when it tries to query that, it'll actually give me the cookie on that GET request. In this case, it'd probably just send me back my cookie. But if this was, say, for somebody else's, if somebody else was viewing this, I might actually get their cookie, because in the HTML, this is what it looks like. It gets rendered as valid script. So that's kind of what it looks like here on the server side. We can see this nice base 64 string, probably the cookie. Well, that's bam, cross-site scripting, script injection. All right, so you kind of get the idea. The idea here with injection is that we're inserting some sort of custom instructions into an otherwise benign statement, something that was intentionally supposed to be like just good. And we're saying, all right, well, since you're not doing validation on my part, so I'm just going to put in whatever I want and you're just going to have to deal with it. And I get the keys to the kingdom. What kind of injection, though, might be coming across? Well, we've already seen code injection and XSS, but there's also the SQL injection. We already seen command, but there's code injection. And so if, say, like maybe there's evaluated Python code in some Flask server, for example, there's an SMTP injection, GraphQL injection. Injection is anywhere really where you have a user input that is not being validated, that's getting put into some already predefined query that's not really having any proper sanitization done to that query, kind of just allowing the attacker just to really do whatever they want, which is very unfortunate. We're going to focus on SQL injection today, though. So basic SQL injection is kind of the classic. We have a login. Me as John, again, I'm going to input my username as John and my password as password. On the back end, the SQL query is just going to take the user field and the password field and insert them into the query. So if they were to take the username and password, this is what it looks like. And this is good. So what it's going to do, if you're not familiar with SQL queries, it's going to select fields, username and password from a table called users, where the username is equal to John and the password is equal to password. So the response should look something like this, where you get a username and a password output and a table, and there was one entry found, John, and then might have like a password hash, because maybe in that translation it passed in a password hash. If I wasn't password hashing and I was actually doing this query like this, it probably show up as password here. Normally, this is fine. We expect this is operating properly. What if, though, I just said, okay, username John, whatever. And then I instead am now inserting what doesn't look like a complete SQL statement. It looks kind of funky. It does or and then 1 = 1. So in SQL land, the query language can operate on operators such as and or. And so you can kind of chain together, as you saw before here. We were actually doing where username is equal to John and password is equal to password. We could have done or, but that may not have been that's actually a problem, becomes a problem, because now say username is equal to John, but the password's not equal to password. We would end up still getting the response back of John, So we'd say, username equals John or password equals password. And the SQL response is, hey, here's a guy with the name John. Here's his record of username and password. But instead of, focusing on maybe how that looks if it was just as an or instead, what if we just inject our own or? So now this looks like John, and then we finish off that quotation mark there, and then we do or one equals one, and then we have this dash dash in the end. The dash dash in certain SQL languages, so for like MySQL, is counted as a comment. And so what we'll do here is we'll comment out the rest of the query. And I think I probably have messed this up a little bit. I believe we'd want to do also a semicolon to end the actual statement. Um, but aside from that small syntax error, the idea here is we want to actually get rid of the rest of the query, because otherwise, if we don't just kind of bash out the rest of the query there that was already there, it's going to fail because SQL doesn't like improper syntax. Go figure. So what we'll do here is we'll comment out the rest of that. And now what the query is looking like is saying, well, if our username is John, or we just, one equals one, and, I'm pretty sure one equals one. So that's going to evaluate to true. And that's going to give us a login. Kind of spicy. It's going to respond to us with the same response, and we get login. Boom, SQL injection. The main thing here to keep in mind, though, with like this specific query is that it actually responds to you with the first entry, because so say we didn't enter in John, or even if we enter in John, this is an or statement. So maybe John didn't evaluate to true, and there was multiple users in here, and John is like maybe at the bottom of the table. One equal one evaluates to true first. Say if we did like John P or something, and so John P doesn't exist. So or one equals one is going to result to true, and it should give us the first user back, or at least a set of users, because all of those users fit the schema of true usually. So in the sense of a login, it might just give us the first user, and we're going to log in as that first user. So if it's admin, which a lot of times it is because that's the first user to be created, then we're just going to log in as an admin user, and that's not too good. But this is something to keep in mind if maybe you're testing this and you want to log in as not admin but another user below admin. So you got to do some fanciness with your SQL query, but I'm not going to go into that too much here. What are the types of SQL injection you might come across? So we have an in-band SQLi. This is usually what kind of we just explained. This is something that you can see an immediate effect of usually, whether that's some sort of output from an error, or this is some sort of immediate like, okay, well, we obviously got to log in. We can see exactly what our query is doing and pretty much have an idea of like what we need to adjust in it. This is as opposed to maybe a blind SQL injection, where we really don't really know what's going on. We kind of just shoot in the dark and don't really know what's going on. Sometimes it might result in, yeah, we successfully logged in. Other times it's just, we're kind of left not knowing what's going on. So this is where we're going to use something of like a time-based blind SQL injection, or some sort of Boolean-based injection, which these tend to give us a heartbeat of some sort of what might be going on in the background. Tools like SQL map and some other popular tools tend to use the time-based SQLi injection whenever it is blind, to basically we'll say like for whatever, say the ordinal value of a is, or some value in a hash, we'll say give us that singular value at that index and then sleep for that amount of time. And the ordinal value is usually the decimal representation of a character value. So say it's lowercase a, that should be 0x61 in hex. I forget what that is in decimal, but it would sleep for that long. And so sometimes SQL queries could take a really long time then if you're trying to sleep for that value of a. But then it's a because it slept for 0x61 seconds. So it's something kind of interesting about that. And it's a little bit harder to do because you don't really know what's going on. You kind of have to, it's usually better to automate this, because doing this by hand is going to be a pain. Out-of-band SQLi is usually you're not going for something where you want to bypass a login. A lot of times this is trying to take advantage of mechanics of the database. In an instance of, say, an MS SQL database, sometimes you can actually just execute straight OS commands. You can just say, command prompt, do a thing for me, whether that's pop a shell or that's add a user. You're taking advantage of advanced features of a database that you're immediately having the ability to inject into to either leverage additional code execution somewhere else in the system, or maybe grant you access to, say, like remote admin or remote WinRM. So these are usually the top three you'll see, and there, of course, there's like there's better ways to define these more discreetly in the subcategories, but I'm not going to define that too much here. Some mitigations to go over, though, is, of course, what I mentioned multiple times before for any of these code injection or so any type of these injection attacks is input sanitization. You want to look at, I have user control data. Should I sanitize it? The answer is always yes. How should I sanitize it? That's a little bit more complicated sometimes because, usually people might do like a filter. So be like, okay, well, I'll filter out parentheses, semicolons, terms that might be looking like SQL queries. That's usually, not as sufficient because people can do crazy things like URL code, or they do your Unicode characters and sometimes get parsed differently. So sometimes basic input sanitization that's just by a filter is not enough. So maybe using something like parameterized queries or types of validators, such as in PHP, they have a MySQL validator function that actually is quite robust and will allow you to put in effectively just like a single query. It'll validate it, tell you if it's bad, or if it has queries that are content in there that shouldn't be in there, or if it is in there, sometimes it'll just yeet it out and then send you the query. And so now, even if they try to do an SQL injection, it wouldn't properly run at all. The query would just die pretty much. Parameterized queries are kind of nice because it allows the database to figure out, okay, well, I have what I want to run, and then I have the user data. And that's kind of nice to distinguish between those, because in this way, the database actually knows I probably shouldn't just like run somebody's query that they're just giving me that isn't the developer. So I usually try to aim for parameterized queries, but there's usually a type of parsing and a type of sanitization method in most modern web backends. So try to use that. Don't implement your own because you might get shot in the foot unless you're really good at it. Really good at regex. You're just like a regex gods. There's some people that are really good at that. If you want to test for this, so last week I had shown a usage of SQL map for performing SQL injection on a Ajax query that was also referencing a MariaDB backend. This is just one tool of many automated tools that exist out there. Some include JSQL injector, NoSQL map, BlySQI. These are all located. I mean, I got this list from Kitploit. There's just one list of many that are out there. You can also do SQLi injection testing with Burp. If you haven't used Burp Suite, I would definitely look into it. It has a really good suite of tools to use. One of them being the fact that you can use it to test for SQLi injections with Burp Community. If you have Burp Pro, I believe there's like better support for that. Otherwise, in the free version, you have to kind of like do a little bit more handholdy. But yeah, so that's kind of a nice little intro on SQL injections. If you have any questions, I can take those now because maybe there's something I forgot to go over.
No, that was really good. And I really like how you did the red on black text. I think that made it really kind of clear, like, okay, this is user input, and how this is how user input is now affecting the how it's going to be parsed by the database eventually. So cool. Good stuff.
That's so funny you said that, because I literally wrote that down. You can't see my paper, but I was going to say the exact same thing because I never know how that fits into the query. I just know that you use that. So
yeah, so usually that kind of thing helped me at least I used to write out like the queries, like what they would look like possibly in the back end, and then try to like figure out how I want to write that in, because sometimes it's like hard. That for me, it's conceptually hard to visualize, so I have to always like write it out.
Yeah. So one question I had though, and I think it might be a little more advanced than sort of just the introductory material here, and could be possibly be another demo, is like, so I think one of the techniques is some of these SQL injection vectors, they use union. So how, like at a very high level, how does that, using union work to sort of find a SQL injection or to validate a SQL injection?
So, and I am not the best at this, but
Okay.
I feel like the usage, if I recall, for using union, is you can use it to basically find like maybe types of fields. So I've used it the most for like, if I don't know what a query is supposed to look like or a table entry is supposed to look like, I might use union to figure out how many fields there are, then the type of fields. So that way, when I chain together multiple SQL injections using union, I believe union, you can say like, okay, well, take like whatever query I have, union, and then the next query I want to run. Either I believe it's either against the data or it's with the data, and you can output it the same to the table. But you'd have to know like what parameters to put there, like what type they are, how many there are. So if you have like 7 fields, 6 fields, 3 fields, if you put more than that or less than that, it will fail out sometimes. And so that's the usage I've seen for union. Someone else might be able to explain that a little bit better, but I would definitely, I wouldn't mind trying to do a talk on that maybe next week. Because I'm not, like I said, I haven't done SQL injections with union attacks a lot. So that's something I can do though.
Nice. Yeah. Because for me, right, I just follow the cookbook and I don't really understand how it's working on the end. But like you're saying, exactly, they're like, okay, add another column, then you'll get like basically a true or false. Like, okay, now you know that. Okay, now on to the next thing, right? But yeah, if we sort of understand how it's working on the back end, that would be awesome.
Yeah, the harder part I see in that that I've come across is like when it's a blind SQL injection with the union attack, and then trying to figure out if that's like, was that right? I don't know. And I believe I've seen in what is it, SQL map, they'll use sleep. They use sleep a lot, and so they'll do some like weird parenthesis escape like 3 times over to try to like pop a sleep. And so if they know that they hit that field, it'll be like it'll sleep for 5 seconds. And they're like, okay, cool.
Another use also with union is like you can exfil from a different table than the query that you're injecting. So you can union select from a second table. But the problem is like Nathan mentioned, like you have to have the same number of columns. But if instead of putting a column name, you can just put like a static string and pad it out to be the same number of columns for the second table you're trying to dump from. And when it gets returned by SQL, it will most likely get parsed by like the PHP code or whatever as was coming from the same table. So it'll just dump out that and you'll see like the code from the table that's originally being queried, then you'll see the data from the table that you were targeting in your union select statement, which is nice for doing like extra Excel.
Nice. For something like that, I probably need a diagram, right? Like it kind of roughly makes sense, but you got a diagram.
Yeah, you have to do a lot of like reasoning out. You have to do a lot of like reconnaissance, figure out, okay, what are my tables? What is the DB engine? Like, what are the column names? Like, how many calls are there? Yeah, there's a lot of like recon you have to do. And I see like SQL Map does a lot of that automated, but like for a lot of like CTF that I do, like you can't use SQL Map because that's cheating. It's kind of lame. So like doing it by hand, it's like, oh, this sucks. It's like, all right, where are the tables? Like, what's the engine? Like, yeah, it's kind of lame.
Awesome.
Hey, if it's a good CTF, you can use SQL map and it won't work.
Yeah.
Yeah, that's true. All right. Cool. Awesome. Thanks.